It's nice to get outside on a spring day like this. The flowers are blooming, green leaves growing everywhere. But have you ever really thought about how things grow in nature? It all happens step by step, cell by cell, minute by minute, day by day. All of this being added together to make every unique creation based on some invisible design. We humans make things in a very different way. We carve out raw materials, pour things into molds, or we make a bunch of parts that we put together to make even bigger objects. Think about it. Nature grows things like trees. Then we break these trees apart to make our own stuff. Nature adds to create, and we subtract. What if we could grow things too? What if we could kind of print out our designs into real solid objects? Now that would be cool.
Additive manufacturing, put quite simply, is precisely what it says. You're manufacturing something by adding. Actually, in the purest sense of the word, we are growing parts because we're adding layer by layer by layer to create virtually any geometry that you can imagine.
The additive manufacturing process is focused on three main areas: 3D computer modeling, 3D printing, and the actual 3D additive manufacturing of products. One of the coolest ways to create a 3D computer model is with a scanner. These devices scan real objects to make digital copies. From there, you can use the data in lots of ways. Once you have the computer model, you can create a physical model using additive manufacturing. Space Labs uses additive manufacturing to design high-tech medical devices and patient monitoring systems for the healthcare industry.
So this is what's been on the shelf for actually quite a while at Space Labs. We were kind of tasked to make a next generation of that. Getting a prototype is very expensive and took a long time to get. Now we can print it out overnight and actually feel a real part in our hand. It shrinks our design process. So it's a lot like a sophisticated hot melt glue gun for this machine. So it comes out through and it comes into this tip here. You can build a layer and the table will go down and build on top of that layer and go down and build and build and build. So it just keeps depositing more and more material and builds layer by layer. You're using actual plastic material, so in the end you end up with a real part.
"3D Systems" is an international leader in 3D printing technology for additive manufacturing.
We can create geometries that can not be built in any other way, shape, or form. So all of this starts with CAD, computer-aided design, and a digital model. So you'll see it on your computer, you will design it on your computer. That computer-aided design model is then sliced like you would a loaf of bread, sliced into piece after piece after piece after piece until you have the entire model in these slices. Now in the case of additive manufacturing, each one of those slices is very, very thin, about the thickness of a human hair. The equipment, instead of trying to draw this entire piece, only starts by drawing the very bottom of the loaf of bread. Draws that very first layer very thin. Then the equipment drops down and another layer is drawn, and another and another and another until it grows this entire part. Stereolithography is when you break it down, just what it sounds like again, Lithography is a printing process, a two-dimensional printing process, lithography. Well, this is done in stereo, so it's printing three-dimensionally. There are a number of artists who are doing things for the gaming world. If you want to make physical objects in the world, whether it's buildings or hearing aids or jewelry, additive manufacturing will play a role. There's also the medical side. Both MRIs and CAT scans that we've all heard about are done in slices. So they take pictures of the human body in a slice. Well, that slice layer then translates directly into additive manufacturing. This shape that you can see inside this block was created from CAT scan data and from stereolithography. What this does is it allows the doctor to practice on running a stent or a catheter into the heart from different locations. If you're at all interested in manufacturing or making things, of designing things, as you go through your formal education process to reach that goal of making things, you'll be made aware of additive manufacturing, and you'll need to challenge yourself as to what else it can do. It is an inbred part of manufacturing today. So, if you're interested in building or making, prepare yourself accordingly.
Going direct to production from the 3D computer model is the new frontier for additive manufacturing, and big challenges lie ahead. That's because we must make next-generation 3D printing machines that can use the new materials to make finished products. The National Center for Materials Technology Education is focused on materials science, and think about it, there are all kinds of materials out there that today's products are made from. Metals, ceramics, polymer plastics, composites, and more. In the future of additive manufacturing, it's all about the materials that these new machines will use. Industry expert Terry Wohlers has some predictions for the future of additive manufacturing.
In the future, we're going to see much broader access to the technology. We'll see low-cost machines that are affordable by almost anyone. New business models are developing to the point where almost anyone located almost anywhere can now be in the product development and manufacturing business. Really, to be a manufacturer, you could operate out of your home, your garage, your dorm room, pretty much anywhere. Few products we buy today have not benefited from the technology, whether it's an automobile or a plane, consumer electronics, power tools, the list goes on and on. There are a few industries that will not be impacted, and some in a dramatic way, by this technology. Really, the next frontier is the development of composites and graded materials. Composites would be materials where you're blending in, say, glass fibers or carbon fibers in with other plastics. And we're already beginning to see companies and universities around the world, a lot of energy being put into developing human body parts with this technology, using 3D printers to print scaffold structures that are the shape of the tissue, whether it's hard tissue such as bone or soft tissue, and then jetting live cells, living cells into the structure. They've shown that they can grow skin, parts of bladder. Their goals really are to create kidneys, eventually hearts. There's just so many directions in so many industries and so many applications within these industries, so many possibilities.
In the end, everything that is made, whether by humans or by nature, will happen step by step over time. Nature will make leaves, cell by cell, plant by plant, every spring. People will build things, like airplanes. They will be put together, piece by piece, until finally they will roll out of the factory and fly away. It's hard to know what's in store for the future of additive manufacturing. Someday, will we be able to just print out our stuff at stores in a shopping mall? Will we find ways to pull atoms together out of thin air to make our products of the future? Who knows? But what we do know is this: additive manufacturing is here to stay. It's the new frontier for manufacturing and for material science. To learn more about additive manufacturing and material science, check out these websites.